A study of the standard slide rule shows that of all scales on the rule, the C and D scales are the ones most commonly used for multiplication and division. Let us review these procedures using a simplified rule with enlarged figures. To multiply 2.5 by 16, for example, first find 2,5 on D, and to it slide the index of C. Move the hairline to 16 on C, and read the answer 4-0 under the hairline on D. The ciphers and decimals required by the problem are, of course, placed mentally. The procedure may be diagrammed like this. 2.5 times 16 equals 40. To review an example in division, say 30 divided by 4. First, find 3 on D, and to it slide 4 on C. Move the hairline to the index and read the answer 7.5 on D. Again, the ciphers and decimals required are added mentally. Division procedure may be diagrammed like this. 30 divided by 4 equals 7.5. When skill has been acquired in multiplication and division, problems in proportion may also be solved with the C and D scales. Let us take the simple proportion 4 is to 2 as 6 is to x. The proportion may also be stated like this, a form more convenient when using the slide rule. To find x, first set the rule to match the known quantities above and below the line, in this case 4/2. Find 2 on D, and to it slide 4 on C. Find 6 on C. Opposite 6, read x as 3 on D. With this problem, x is to 2 as 6 is to 3, the known quantities above and below the line are 6/3. So we find 3 on D, and to it slide 6 on C. Find 2 on D, and read x as 4 on C. With this, as with any setting of the rule, all coinciding readings are in the same ratio to one another. Thus we may read 4 is to 2, as 6 is to 3, and as 8 is to 4, as 10 is to 5, as 3 is to 1.5, as 2 is to 1. Also, using larger numbers in which positions must be estimated, 4 is to 2, as 51.4 is to 25.7, and as 3490 is to 1745. In proportion, as in multiplication and division, the ciphers and decimal points must be placed mentally. Suppose now we wish to extend the equation to 4 is to 2 as 12 is to x. We see that 12 is past the body of the rule. If the C scale repeated itself, we could read as 12 is to 6. Actually, the C scale can be repeated, in effect, by placing the hairline on the right index and then sliding the left index to it. In shifting from one index to the other, the ratio remains unchanged. In this case, the rule is still set in the ratio of 4 to 2. We can read 4 is to 2, as 12 is to 6, as 15 is to 7.5, as 20 is to 10. Now, to take a typical problem in proportion, here is a post 30 feet high, casting a shadow 5 feet long. The tower casts a shadow 54.5 feet long. How high is the tower? The problem may be stated in terms of proportion. 5 is to 30 as 54.5 is to X. To 3 on D, slide 5 on C. Push the hairline to 545 on C. Under the hairline, read the answer 327 on D. The height of the tower is 327 feet. Suppose the problem is to convert inches into millimeters and millimeters into inches. Since 1 inch equals 25 4/10 millimeters, we write 1 is to 25.4, as 1.6 is to X, as Y is to 43.2, as 8.5 is to Z. To 254 on D, set 1 on C. Move the hairline to 16 on C and read X as 406 on D. Move the hairline to 432 on D and read Y as 17 on C. Now, since 8.5 is off the body, we must shift to the other index. Set the hairline to 8.5 on C and read Z as 216 on D. Again, placing decimal points in terms of the problem, we have 1 is to 25.4, as 1.6 is to 40.6, as 1.7 is to 43.2, as 8.5 is to 216. Problems in percentage may also be worked by proportion. Of 285,000 men, 91,000 are skilled workmen, 176,000 unskilled, and 18,000 unemployed. What is the percentage in each group? 285,000 is 100%. Find the percentages of X, Y, and Z. Stating the problem in terms of proportion, 285,000 is to 100, as 91,000 is to X, as 176,000 is to Y, as 18,000 is to Z. To 1 on D, set 285 on C. Under 91 on C, read X as 319. Since 176 is beyond the body, shift to the other index. And under 176 on C, read Y as 618. Under 18 on C, read Z as 63. As a final step, add the decimal points. Notice that with any setting of the rule, all coinciding readings are in the same ratio. With this setting, 285 is to 100, as 91 is to 31.9, and with a change of index which leaves the ratio unchanged, as 176 is to 61.8, as 18 is to 6.3. With this setting, 4 is to 2, as 6 is to 3, as 8 is to 4, and so on. It is this feature of the C and D scales which permits the ready solution of problems in proportion and percentage. The C and D scales, together with two others, the A and B scales, are used to obtain squares and square roots. The A and B scales are made as though the C and D scales were contracted to half their length and repeated. On the A and B scales, there is not room for as many marks as on the C and D scales. Within these brackets, each smallest division is read as a 2. For example, 100, 102, 104, 106. 100, 102, 104, 106. Within these brackets, each smallest division is read as a 5. For example, 200, 205, 210, 215. 200, 205, 210, 215. Within these brackets, each smallest division is read as a 10. For example, 500, 510, 520, 500, 510, 520. In obtaining squares and square roots, use the B and C scales or the A and D scales. To square a number, 8 for instance, place the hairline on 8 on D. Follow the hairline up to the A scale, and under the hairline read the square 6-4 on A. Conversely, the square root of 64 is 8. The procedure for obtaining squares always takes this form. The procedure for obtaining square roots always takes this form. Notice that to obtain the square roots of single-digit numbers, the left half of the A and B scales is used. Of two-digit numbers, the right half. If we try to obtain the square root of 4 on the right half, we read 632, which of course cannot be the answer. If we try 40 on the left half, we read 2, which of course is wrong. Remember, in finding square roots, use the left half for single digits, the right half for two digits. With numbers of more than 2 digits, mark off in pairs from right to left. Here, a single digit remains to the left of the mark. Use the left side. With this number, 2 digits remain to the left of the mark. Use the right half. With this number, use the left half. If the number contains decimals, mark off in pairs to the left from the decimal point. In this case, since 2 digits remain, use the right side. If there is no figure ahead of the decimal point, mark off in pairs to the right from the decimal point until a figure which is not a cipher is included in a pair. If the first figure in this pair which you have marked off is a cipher, use the left side. But if the first figure in the marked off pair is not a cipher, use the right side. In any mathematical problem, it is of the utmost importance that the decimal point be correctly placed in the answer. In obtaining squares and square roots, there is a simple means for placing the decimal point. Take this problem, for example. We read the answer 1875. Where does the decimal point belong? 1 under the 3 the 8 under the 52, the 7 under the 51. The 5 is left. Place it to the right of the decimal point, and we have the answer 187.5. With this problem, place the decimal point for the answer, place a cipher under the pair of ciphers, the 1 under the next pair, then the 875. The answer is 0.01875. If the decimal point were here in the problem, place the decimal point, then the 1 under the pair, then the 875. The answer is 0.1875. If the problem is to square a number, we merely reverse the procedure in order to locate the decimal point correctly in the answer. Reviewing squares and square roots, read up to square a number. Read down to obtain the square root. Determine whether to use the left or the right half. Locate the decimal point by this method. As an example of a practical problem involving squares and square roots, a piece of land is in the shape of a right-angled triangle. One side measures 150 feet, another 65 feet. What is the dimension of the long side, x? X in this example is the hypotenuse of a right-angled triangle. We know that the square of the hypotenuse of a right-angled triangle is equal to the sum of the squares of the other two sides. In other words, x squared equals 150 squared plus 65 squared. Then, x equals the square root of the sum of 150 squared and 65 squared. We square 150 and obtain 22,500. Square 65 and put down 4,225. Adding these, we get 26,725. The square root of this figure will be the hypotenuse, x. By marking off, we see we must use the left side. Placing the hairline on the estimated position for 2, 6, 7, 2, 5 on A, we read 1, 6, 3, 2 on D. By lining up the figures thus, we find that x equals 163.2. With any right-angled triangle where two sides are known, the finding of the unknown side involves only the simple process of obtaining squares and square roots. Careful practice is essential to using the slide rule with speed and accuracy. But facility and D scales makes possible the ready solution of problems in multiplication, division, proportion, and percentage. Using the A and B scales with the C and D scales, it is possible to obtain quickly both squares and square roots. And these are only a few out of the wide variety of problems that can be worked with the standard slide rule.